Please note, this course is an overall worker safety presentation. This course is not providing any continuing education credits. This is part of the two-day presentation discussing worker safety. Days 1 presentation covered some of the same topics being discussed today. However, if you missed it, Day 1's presentation was recorded, and it will be posted for you to watch on our website. We have a lot of information to share with you today, and at the end of today's course, participants will become familiar with Local Law 196 of 2017. This is an overview of the safety training requirements. We will review trenches and excavation, notification requirements, their hazards, and tips on how to prevent incidents. We will also review control access zones. This will be an overview of case studies, hazards related to them, and how to prevent them. We will also review fault prevention. This will be an overview of case studies, the causes, and how they could have been prevented. And most importantly, workers' rights. Here we will discuss every worker's rights on construction sites and how to report unsafe working conditions. In the end, we will have a brief Q&A session. Any questions we don't get to answer tonight will be posted with the presentation for everyone to view. So let's get started with our first topic, Local Law 196 of 2017. Due to the increased numbers of incidents in recent years, Local Law 196 of 2017 has been implemented. This law requires construction workers to have 30-hour OSHA training or have a 10-hour OSHA training and 20 hours of approved Department of Building Safety training. Please keep in mind, starting on March 1st of 2020, those requirements will increase to 40 hours. This is a combination of 30 hours of OSHA training, an 8-hour of fall protection, and with 2 hours of drug and alcohol awareness. Another way to meet the requirement is by taking the 10-hour OSHA training along with the following DOB-approved safety trainings, which consist of 8-hour fall protection, 8-hour Chapter 33, 4-hour supported scaffold, 2 hours drugs and alcohol awareness training, 4 hours of general electives, and 4 hours of specialized electives. Local Law 196 identifies who requires safety training. As you can see by the list, construction superintendents, site safety coordinators, site safety managers, competent persons, construction workers, and those are just to name a few. However, please note it shows employees of DOB licensees and employees of DOB registrants. If a DOB licensee or registrant has a worker accompany them to a construction site and are actively engaged in construction activities, those unlicensed workers must be fully trained to work alongside the DOB licensee and the registrant. Local Law 196 also identifies workers who don't require safety training. That list includes building site owners, developers, project managers and construction managers, delivery persons, flag persons, special inspectors and consultants, security officers, and service technicians, and those are just to name a few. An excellent example of not requiring training would be a company that is delivering appliances and are bringing them to a newly finished apartment. They would not be considered part of the construction crew. Local Law 196 also requires the issuance of site safety training cards. These cards are needed for all active sites requiring a site safety professional. A construction superintendent is required to oversee on construction sites up to 9 stories. A site safety coordinator is required to oversee safety on construction sites 10 and to 14 stories. A site safety manager is required to oversee safety on construction sites of buildings 15 stories and higher. Below is a link of the department's online map that shows active sites. With a site safety professional requirement, anyone can verify if their site requires an SST card. Here, we are showing a few do's and don'ts for our safety professionals. A do consists of items as signing the logbook every day, maintaining a presence on the site while work is being performed, designating someone as a competent person in the absence of a construction super. Keep in mind, construction supers are the only ones that can designate a competent person for their site. When a construction super designates a competent person, they need to indicate who specifically is the competent person during their absence in the logbook. They must also have them sign and acknowledge that they are the competent person before leaving the site. Please note, the person picked to be the competent person must have the required SST supervisory card or the required trainings. We will be discussing this in the upcoming slides. Additionally, site safety coordinators and site safety managers are required to maintain a presence during all construction activities. For don'ts, we want to remind you not to forget to sign the logbook. This is very important. It shows you are on the site and performing your duties. Construction supers shall not leave the site without first designating a competent person. Construction supers shall not leave the site without documenting who the competent person is that is taking over for them. This is very important. We can't stress this enough. And site safety coordinators and managers cannot leave the site during construction activities on their site. The competent person is an extension of the construction superintendent in their absence. A competent person should be a worker who has the ability to identify hazards and the authority to stop unsafe activities. Competent person must have the required supervisory 62-hour safety training. The trainings consist of 30-hour OSHA, 8-hour fall prevention, 8-hour site safety manager refresher, chapter 33, a 4-hour supported scaffold, 2 hours drug and alcohol awareness, 2 hours of site safety plans, 2 hours of toolbox talk, 2 hours of pre-task safety meetings, 2 hours of general electives, and 2 hours of special electives. This list can be found on our website, and the link will be shown at the end of the presentation. Some do's to be aware of if you're selected as the competent person. You need to maintain a site safety presence at all times. Stay on site during active construction or until you are relieved from duty. Be knowledgeable on the construction activities being performed. Keep up to date on training. Keep up to date on new means and method. Stop any unsafe activities. Some don'ts for being the competent person is don't ignore safety regulations. Don't leave the site without being relieved. Don't be inexperienced or a novice. Don't take on more than you can actually handle. Don't be afraid to report issues or concerns. Remember, safety is everyone's priority. The next topic, we will be discussing cold-formed steel construction, including incidents and their hazards. We will review case studies which resulted in injury or a fatality, what caused them, and how they could have been prevented. Please keep in mind, every site is different, and prevention measures shown in this presentation may differ from site to site. Not all solutions are suitable for every site. C-joists are engineered products that perform differently than wood joists. C-joist components provide an economical, lightweight alternative to open web steel joists, cast in place, or hollow core floor assembly systems, and engineered wood joists. C-joist comes in a variety of depths, flange sizes, and steel width. Cold formed steel are commonly used in 1 to 4 story new building construction. It allows for quicker installation of multiple stories due to its light weight. A special inspector must verify the construction of cold formed steel during its installation. The professional engineer must inspect and approve prior to placing any loads. In this slide, we have a comparison of wood joists versus C-joists. Here you can see the major differences between the two materials. Some highlights are timber joists weigh around 7 pounds per linear foot versus C-joists, which weigh around 3 pounds per linear foot. These measurements are based on a 10-inch joist. Timber joists are not easily accommodating for pipes and ducts, whereas C-joists are manufactured with mechanical pass-throughs. This chart also shows the factor of safety takes into account for design errors, material defects, and connection errors. With that in mind, wood joists have a factor of safety of 8, when compared to C-joists, which have a factor of safety of 0.5. And when it's fully installed, the factor of safety is then increased to 2.5. This shows how important it is that C-joists are installed per the manufacturer's recommendations and the engineer's plans. Due to the number of incidents through the years, the Department of Buildings have published C-joist system awareness handouts to address bracing and overloading issues. The department has also embarked on an industry outreach campaign that includes C-joist manufacturers and providers. The outreach notification informed the industry of the following: don't place any loads on decks before properly mounting, fastening, and connecting the C-joist system together. Decks must be completely fastened to the C-joist system before loading. Never overload a deck. Review and follow without deviating from the design drawings and the manufacturer's specifications. We will show you examples of these in the upcoming slides. Keep in mind that these photos do not take into consideration the overall stability of the structure. It is the responsibility of the licensed professional to design the floor diaphragm and all of its relevant connections, and to take into account wind and seismic loads in the layout. Precautions must be taken to avoid construction overloads and exceeding design live loads. Temporary bracing must be installed at the time of installation. It is not to be left out. They are harder to install after the fact. The joist bridging must be installed when the floor is constructed. Failure to install the bracing at this time may compromise the structural integrity. This is for your safety as well as others. Notice the number of required parts it takes to properly brace the co-form deck. The flat straps on the top and the bottom, joist blocking, screwing straps, make sure they are screwed into each brace and joist, and the decking must be completely fastened to the C-joist before loading system. All these listed parts are needed in order to secure the system. Again, failure to install the bracing at this time may compromise the structural integrity. We cannot emphasize this enough. Keep in mind, the manufacturer's specifications are part of the approved drawings. The system will fail if it's not followed. The system is not secure until all supports, web stiffeners, and connections, along with the bridging, are properly installed. Pour the lower floor first, before installing the upper floors, to help carry the loads of the upper floor. The key is to tie all the walls together. During construction, placing even light materials on the unbraced top flange of the C-joist can cause instantaneous sideways buckling. It is an instant, progressive collapse of all the joists, resulting in a large opening. Keep in mind, C-joist bracing is critical in the stability of co-form steel structure, and in the installation of the top flange bracing is very critical. Even in different configuration, until fully installed and braced, C-joists can be structurally unstable and occasionally can collapse without warning. Remember the factor of safety, the cold form steel? It's 0.5, and when it's fully installed, the safety factor is then increased to 2.5. It must be installed per the manufacturer's specification and the approved drawings, or it will fail. As a reminder, cold form steel collapses, and very rapid and progressive. It often comes without warning and does not leave enough time for the workers to evacuate. The incidents are usually associated with overloading a platform or not properly fastening and tying the system together. I know some of these are repetitive, but it's only to emphasize its importance. The typical cause of the collapse are usually due to overloading in areas that are not braced or ready for a load. Stiffeners, bracing, and bridging are usually missing in these incidences. And failure to pour concrete floors below can cause the exterior walls to buckle, as you can see from this picture. This incident occurred in the Bronx on August of 2019. A new 4-story cold form steel construction with CMU blocks. An overloaded elevated deck collapsed. When the load was placed on it, the front half of the 3rd floor deck fell onto the 2nd floor with workers underneath it. As a recap, this building received a delivery of CMU blocks which were delivered onto the 3rd floor deck. The deck was not fully installed nor braced. The 3rd floor deck was still in the framing stage and was not shored and braced against rotation or lateral movements. Other workers were staged and working on the floor below. When the CMU was placed on the deck, it triggered the collapse and caused death to 1 worker and injured 5 others. Some of those injuries were buried in the collapse and had to be rescued. Key prevention takeaways for this incident are: prior to loading the deck, ensure it is properly installed per the manufacturer's and the PE's instructions, which we can't stress enough, as this is one of the leading major issues for cold form steel. Never store materials or equipment on the floors that are not fully constructed or braced. And prior to placing a load on a deck, verify with a PE that it is safe to load. This incident occurred in the Bronx on August of 2019. This is another example of a C-joist that rolled over and collapsed when it was loaded. The C-joist and materials struck 2 workers when the unbraced floor was loaded. This incident involved an 8-story building where, again, CMU blocks were being delivered to an unsecured deck on the 7th floor. The C-joists were not braced and tied, and the floor decking was missing when it took the load. And this collapse caused 2 workers to be injured. Key prevention takeaways for this incident are: a daily pre-shift meeting and toolbox talk to review the work and identify dangers. Workers should have 30-hour OSHA training, fall protection training, and site safety training. Fastening and securing with a pre-inspection should have occurred prior to loading. Complacency can cause workers to think that they will never be injured. Even if it's done multiple times, it only takes 1 time for something to happen. Patricia will now present trenches and elevations.
Thanks, Ozzy. Now that we've learned about cold form steel, let's move on to trenches and excavations. In this segment, we will discuss hazards, requirements, incidents and preventions, and we will wrap it up with some safety tips. After all plans and drawings have been approved and permits are issued, the first thing to do before the start of chipping, digging, or blasting is to notify DOB. Let DOB know 1 to 2 days before any excavation work starts. Call 811 before digging. A ticket number will be issued. Then call 212-393-2550 with the ticket number. Without the proper safety precautions in place, excavation and trenching are among the most hazardous construction operations. Without guardrails, a worker passing by can fall in. If equipment is not properly supported, it can tip in. Cave-ins can trap workers, which almost always cause a fatality. Workers can be struck by moving heavy equipment. Excavation or trenches 5 feet or deeper require shoring and bracing, or 45-degree angle of repose, with each step not being higher than 5 feet. When the depth of a trench or excavation is greater than 4 feet, it is required to perform air monitoring as oxygen becomes deficient. Poorly ventilated trenches may fill with hazardous gases or liquids. Other hazards include landslides and rock slides, which can trap workers and machinery in their path. To put this into perspective, a single cubic yard of soil weighs about 3,000 pounds, which is the weight of a small car. Building codes are in place to help mitigate hazards. The first step in preventing incidences from taking place is to build a construction fence prior to excavating. The construction fence is required to be 8 feet high and built solid for their entire length. A construction fence should be installed in order to protect the workers and the public from any hazards related to the excavation. Here we can see 2 examples of a construction fence. To the left, we can see a construction fence that is not maintained. Please note, half of the construction fence is on the floor. On the right is an example of a properly constructed fence that is built of wood, 8 feet high, and fully enclosing the site. The first line of defense a worker has when working by an excavation are guardrails. Guardrails are a key visible reminder that there is an excavation and that workers need to be mindful of what is going on around them. Guardrails protect workers from accidentally falling into the excavation. The guardrails shall be made up of a top rail, which should be between 39 to 45 inches above the floor, a toe board, which should be 3.5 inches high with no more than a 1/4 inch gap between the floor and the bottom of the toe board, and the mid rail, which should be halfway between the top rail and the toe board. The other option for a guardrail is a solid enclosure of 3.5 feet. On the left, we see an example of an excavation with a trench box, but no guardrails. While on the right, we see guardrails in place with safety netting for additional protection. The guardrails help protect the workers walking by the excavation, as well as those inside, as it limits the possibility of something or someone falling into it. This is the first incident that we will be reviewing. It took place in Queens in January of 2019. The supportive excavation collapsed into the construction site along with 40 feet of the boulevard. Workers informed our inspectors that they were concerned for their lives while they were working in the excavation. If you see something that does not seem right, please bring it up to the site safety professional. Here, supportive excavation was not maintained, nor was it built according to the approved plans. On the right side of the photo, there are soil nails. which was supposed to be placed every 5 feet in both directions. If you look closely, you can see they stopped placing the soil nails towards the bottom, as the workers were told it did not need to be done. What you can't see was the soil nails were supposed to be grouted as well, which was also not done. As they were working, the workers noticed the walls were bulging at the bottom. If you look to the left by the waterproofing membrane, the top of the wall was 24 inches thick and the bottom was 8 inches thick. Because the wall behind it was pulling out as they were pouring the foundation, eventually the pressure caused the wall to blow out. This collapse caused a gas explosion and a water main break, which had to be shut down. The boulevard was also shut down to traffic. An important element to preventing incidents on construction sites are the daily pre-shift meeting and toolbox talk. These meetings should identify the tasks of the day and identify any hazards associated with those tasks. One cannot protect themselves if they are not made aware of the risks and hazards of each operation. All drawings have the factor of safety associated with the design. However, the factor of safety only takes into account minor material defects or installation errors. Factor of safety will not compensate for missing all of the lower soil nails from not being installed and properly set. The weight of the adjacent road collapsed into the excavation due to not installing the supportive excavation according to the approved plans. When performing these operations, it is standard to monitor the movement of the walls. Had monitoring devices been installed and utilized, there is a strong possibility that the collapse would not have occurred. The monitoring device would have raised a red flag to the PE or the super. They would have stopped and analyzed the situation and determined the issue and how to remediate it. Moving on to how to protect an excavation. Per the DOB building code, all sides of an excavation with a depth of 5 feet or more shall be supported by either installing sheeting, shoring, or bracing, or the side slope are not to be steeper than 45 degrees, or stepped so that the average slope is not steeper than 45 degrees. There should be no step more than 5 feet high. To the left, we have a picture of an excavation with the support of excavation missing. The picture on the right shows the proper support of excavation in place. Here we see the soldier piles and lagging is providing the needed support to hold back the soil from collapsing into the wall. In this next comparison, on the left, we have a picture of another excavation. The trench box is missing in this case. A trench box is typically used when performing utility work or working in small spaces. The picture on the right shows a worker in a trench box, which are usually 8 to 12 inches thick. Again, on the left, we see a picture of an excavation, and there is no support of excavation, no trench box, and no angle of repose. On the right is a diagram showing an angle of repose. As a reminder, the side slope are not to be steeper than 45 degrees or stepped so that the average slope is not steeper than 45 degrees. There should be no step more than 5 feet high. Another potential hazard that workers are at risk for is caught in between. A worker can be caught in between heavy equipment or objects and sides of the excavation. The work going on in a trench may also create a hazard. For instance, when laying pipe in a trench, a caught in between hazard exists because workers can get caught in between the pipe and the trench walls. Anything being placed into the trench or excavation may be a hazard, including the protection system. Workers must be careful while installing the protection system so they are not caught in between the trench walls and the protection system. Keep heavy equipment away from edges of trenches and excavations, as it should be 1.5 times the depth of excavation until shored and braced. Trenches or excavations can be very dangerous when they have water inside. The water can soften the soil and cause it to collapse. Workers should not work inside an excavation where water has accumulated or is accumulating unless it is controlled by using pumps or other equipment. Water in an excavation can undermine the size of the excavation and make it difficult for workers to get out. Workers should not enter an excavation where water has accumulated or is accumulating unless adequate precautions are taken to protect workers. Such precautions can include special trenching and excavation support or shield systems to prevent cave-ins, water removal to control the water level, or the use of a safety harness and lifeline. Here are some safety tips to keep in mind for when you are around trenches and excavations. Before getting inside a trench, the trench should be inspected. Keep loads and spoils at least 2 feet from the edges of trenches and excavations. Do not work under a raised load. Know where underground utilities are located. Test for low oxygen, hazardous fumes, and toxic gases. Ozzy will now continue with controlled access zones.
Thanks, Patricia. In this topic, we will discuss control access zones. We will review case studies which resulted in injury or a fatality, what caused them, and how they could have been prevented. Areas designated as controlled access zones must be visibly and clearly marked to alert the workers of the presence of a risk in that area. Wires, tapes, or rope control lines may be used to identify the hazardous areas. The control lines must be flagged at intervals of not more than 6 feet with high visibility material. Control lines must be connected to both sides of the wall or a secure guardrail system and must run parallel along the entire length of the leading edge. They must be strong enough to withstand the force or an impact of at least 200 pounds per square inch. Risk is higher in all directions of an established control access zone. Avoid the control access zone area if you are not working in that area. Workers should be trained in the proper use of fall protection equipment, the procedures of working in a control access zone, and know the hazards. Incorporating fall protection requirements into everyday activities will ensure worker safety in areas deemed hazardous of the potential of serious falls. When in a control access zone, workers must be tied off, as they may not have access to guardrails, safety nets, and a personal fall arrest system to rely on. When in a control access zone, ensure you are aware of the boundaries. Establish the restricted area and the limitations. In general, do not engage in unsafe activities, especially when in these areas. This incident occurred in Manhattan on January of 2019. The worker fell from a 6th floor to the 5th floor. The opening was covered with an unsecured plywood, which was not properly marked, causing the worker to slip and fall. The plywood lacked any markings or warnings that a hole was present. No signs were posted in the area with an indication of the opening. No control access zone was placed in this area either. Prevention measures should have included having a daily pre-shift meeting and toolbox talk to review the work and identify the dangers. Workers should have 30-hour OSHA training, fall protection training, and site safety training. The opening should have been covered with plywood, screwed down, and clearly marked. Workers need to be aware of their surroundings when walking on a construction site. If you see a hazard, report it. Complacency can cause the worker to think they will never be injured. This incident occurred in Manhattan on September of 2019. A panel fell during stripping operations on the 26th floor. A worker was walking underneath the work area when the panel fell. When DOB arrived, it became apparent that stripping operations were not clear to the workers. The removal sequence was not being followed at the time of the operations. A control access zone was not established around the fall zone area during these operations. Preventative measures should have included having a daily pre-shift meeting and toolbox talk to review work and identify the dangers. Workers should have had 30-hour OSHA training, fall protection training, and site safety training. Establish a control access zone with the proper means and method to perform the operation safely. Provide signage and set up monitoring during operations. And be mindful the potential areas where debris can fall. Patricia will now discuss fall protection and leading edge.
Now that we learned about controlled access zones, we will continue learning about fall protection and leading edge hazards. We will touch on overview, anatomy of a fall, incidents and prevention, and fall protection systems. Falls are the leading cause of injuries and fatalities in New York City construction at 38% and 58% respectively. There have been 12 fatalities each year from 2016 to 2019. In 2016, 50% of the fatalities were related to the lack of fall protection. 6 of the 12 fatalities could be alive today if they were wearing fall protection. In 2017, 83% of the deaths were preventable with fall protection. In 2018, 25% of the fatalities were due to falls. And in 2019, 58% of the fatalities could have been prevented. 7 of the 12 workers could still be alive today if fall protection measures were in place. Having appropriate fall protection measures in place means that the site is set up to help prevent workers from falling off overhead platforms, elevated workstations, or through holes. Fall protection is required when work is being performed in an area above 6 feet, a lower level, as discussed earlier in excavations and trenches. Fall protection is also required when working on a scaffolding over 10 feet in height or when climbing a fixed 24-foot vertical ladder without a cage. In the next slide, we will discuss how we unconsciously react while falling. I find the information on this slide to be intriguing. I found it very interesting to learn that a person will fall 2 feet before they even realize they are falling, and it takes 1/3 of a second to fall those 2 feet. It will take 2/3 of a second for the body to start reacting to a fall, and by that point, they would have fallen 7 feet. It takes only 1 second to fall 16 feet and 2 seconds to fall 64 feet. Think about that. In double the amount of time, just 2 seconds, a person will fall 4 times the distance, 64 feet, which is equivalent to a 4 to 5 story building. This incident happened in Brooklyn in April of 2019. A worker was unloading delivered materials when he tripped and fell. He fell through a hole as the floorboards were not in place since the joists were not secured. Although the worker was wearing the fall protection required, he was not clipped in and tied off. An important method of preventing an incident is by being aware of potential hazards that will be encountered while performing the operations. Workers are informed of potential dangers during pre-shift meetings and toolbox talks. If the area is going to be trafficked, every effort should have been made to secure the floor joists so the boards could be laid out. Setting up guardrails are a visible reminder that there is a 6-foot drop nearby. However, all the precautions can be put in place, but if you are not wearing your PPE appropriately, you're putting yourself at risk. This incident took place in Manhattan in April of 2017. The workers were working on a gut rehab. A worker was demoing steel beams from the structure. The worker was throwing debris and demoed steel through the opening onto the first floor. The steel members being removed had lugs welded on it. As he threw a piece of steel to the first floor, through the opening, a lug caught onto the worker's belt loop and pulled the worker, and he went through the hole, falling 20 feet to his death. Had the worker been tied off, he would still possibly be alive today. Preventative measures that should have taken place are pre-shift meeting, which is the appropriate time to initially let workers know of the hazards and precautions that should be taken with each task that is performed. When working near openings, it is required to wear a personal fall arrest system and be tied off. Set up guardrails around the perimeter of openings where possible. To the left, we have a picture of a leading edge, a guardrail with a top rail, toe board, and mid rail. Halfway in between the two endpoints should have been installed. On the right, we can see how 2 guardrails have been installed with the added protection of netting. The netting will help prevent objects from falling onto the lower levels. In September of 2017, workers were lifting a Perry system. The workers had loosened the clamps and pulled the Perry system straight up the wall on the rails. The issue encountered by the workers was the wall was a backset exterior wall. The workers got on the Perry system with crowbars. Instead of loosening the bolts and taking it off, the workers used the crowbars, placing the crowbars between the Perry system and the steel. They used the crowbars to pull the steel away from the concrete. They did this with 8 workers still on the Perry system. As soon as the workers were able to pull the Perry system from the concrete, the system started to sway and the workers lost their balance. One of the 8 workers was not wearing a personal fall arrest system, and he fell 27 stories to his death. Preventative measures should have included a pre-shift meeting and toolbox talk, addressing the risks and the jumping procedures. Workers should have been reminded to follow the manufacturer's instructions. No worker should have been on the Perry system at any point while jumping the system. And all of the workers should have been inside the structure, wearing a personal fall arrest system and tied off. Workers should never ride materials that are being lifted. Here is a comparison of fall protections. On the left, we can see a worker who appears to be approximately 10 feet off the ground. He is working on unleveled boards that are between 2 distinct scaffolding systems. He's not wearing a harness, he's not tied off. The plank the worker is on should be level, and he should have been wearing a personal fall arrest system as he is near the leading edge. On the right, the worker is tied off in the basket and working in a safe manner. Proper work planning can eliminate most situations where a personal fall arrest system is required. Most likely you will experience some type of injury if you are involved in a fall event. Personal fall arrest systems should be used when other fall prevention means cannot be used or are not feasible. Personal fall arrest systems are used to protect a worker from hitting a lower level once they have fallen. Components of the personal fall arrest system include an anchorage point, body harness, deceleration device, connectors, which are lanyards, rope, grabs, and anchorage connectors. A harness needs to be inspected before each use by the worker and checked and documented annually by a competent person. Harnesses should never be modified. It should be taken out of service immediately if found defective or exposed to an impact. Workers using fall arrest equipment should always position their anchorage point above the D-ring to minimize the free fall distance. The illustration demonstrates how minimizing the free fall distance can be achieved. The use of retractable lanyards is always preferred when using fall arrest equipment because the total fall distance is usually 2 feet or less. Here on the left is an example of working on the leading edge without a harness or being tied off. Should there be an incident and the worker were to fall, nothing would be there to save him. On the right, another worker is also working on a leading edge. As he fell, his harness and lifeline saved him and prevented him from falling further. In this near miss, a worker fall took place in Manhattan last year. A worker was installing a railing on a crane tie when he slipped and fell off the crane tower, as you can see in this video. Fortunately, the worker was wearing a personal fall arrest system. The harness and lifeline prevented him from falling to the ground. The other workers lowered the crane, and the worker climbed onto the headache ball and was pulled up to the top of the tower crane. Wearing the harness and being tied off saved his life. This diagram shows the hierarchy of control for prevention. The most effective method to prevent incident is to eliminate the risk by physically removing the hazards. If it is not possible to remove the hazard, the next best option is to substitute the risk involved. The next control option would be installing engineering controls to isolate workers from hazards. An example of this is the installation of guardrails. Administrative controls would be to change the way workers are performing tasks, and if no other control method is possible, then workers should wear personal protective equipment. Different types of fall protection systems are guardrail systems, safety net systems, personal fall protection system, warning lines, designated areas, controlled access zones, hole covers. Now Ozzy will continue talking about workers' rights.
Thanks, Patricia. We will wrap up the presentation with workers' rights, how to report a safety issue, protecting yourself, and how to report any incidences. First and foremost, workers have the right to a safe workplace. In order to ensure worker safety, workers have the right to receive training and information on hazards and how to prevent them. Workers have the right to review records of work-related injuries and illnesses that occurred on the workplace, receive copies of the test results, and copies of the monitoring performed to find and measure workplace hazards. Workers have the right to receive copies of workplace medical records as well. Workers have the right to participate in an OSHA investigation. Most importantly, workers have the right to report hazards and safety concerns without fear of any retaliation. The first step in keeping yourself safe is by being aware of your surroundings and knowing what is going on around you. It is important for you to know your rights. And one of the rights is to have the right to a work in a safe environment. You can yourself be safe by being trained, and a few ways is with site safety training, such as fall protection, scaffold training, but also training on how to use your tools, equipment, and machinery correctly. If you feel you are working in an unsafe construction site that's one of the hazard condition and is placing you at risk, you can lodge an anonymous complaint with 311. In the case of an emergency, call 911. If it's not an emergency, please reach out to the Department of Buildings by calling 311 or call DOB by 212-602-0431. If an incident takes place at your site, please notify your site safety supervisor and your site safety professional. Stay at the site until the safety investigator arrives and provide directions. If you would like to learn more about the rights, visit nyc.gov/NYC Safety. For more information regarding worker safety, please go to the link shown. If you have any question regarding training requirements, please contact DOB. You can email at locallaw196@buildings.nyc.gov for those questions. This concludes our presentation on Worker Safety Day 2. Tim, Ron, Christian, and Wilson have been answering questions via chat, and we are now going to open up the floor for some questions and review some of the most asked questions. A copy of this presentation will be posted, and all questions not answered tonight will be provided for review. So let's see what we have. Okay. All right. I see we're getting a lot of questions on SST requirements. So SST training requirements, do they apply to those installing appliances? How about final cleaning companies? Again, as the example that we provided before, someone coming in that is not part of the active construction site and performing construction is not considered part of the construction crew. So cleaning companies or anything else would not be considered part of the construction crew or considered being part of the active construction site. Let's see. So if a construction super goes on vacation, actually, this is a really good question. So if a construction super goes on vacation or they get sick, do they have to be replaced with another construction super on the PW2 or just make a notation on the logbook? What DOB requires is that if a construction super can be designated in the logbook, as long as the construction super is not away for more than 2 weeks. An alternative construction super can be replaced on the PW2, but it would need to be filed. And that's a key point. You have to remember that if it's going to be more than 2 weeks, you have to update the system in the records in our system and ensure that the replacement is listed. Does the alternative construction super need to be registered or licensed construction super? Yes. DOB requires license, registration, construction super to be designated. Key point, you have to make sure they are designated. Let's see. We're getting some code questions on the new codes. Again, those code questions and everything else, a lot of the information, and I'm noticing a couple of other questions. When it comes to anything with regards to the new codes or current codes or anything else, a lot of that information can be found on the website. If it's not on the website, it would be shortly on the website indicating when those days are, when things are coming into effect. So the website, which I'm going to go back on so you guys can go to, which is again is the safety page or anything else that will lead you to also the main DOB question and sites. You'll have all those answers and questions there. Again, if you have other specific questions that you can't find online, you could always email the department and we will provide an answer. see. That's code questions, which we've covered. So plywood. Plywood again, and if you remember the slide that we had shown up above, does have a capacity of safety when it's loaded. The main key to that slide was that it was not screwed down or fastened down in a manner where when the worker was walking by, he tripped and it slipped and pushed the plywood, which is why he fell through it. So the key point was making sure that it was actually tied down or protected around so that no one could just trip, slip, and fall on it. Appreciate the comments. Both Patricia and I put a lot of work into both these presentations, so we're both thankful for all the compliments we are getting on this. So the presentations will be posted on our website. Usually, I believe it's going to take close to 2 weeks. And when the presentations are posted, they will be posted with the questions we didn't answer, or if we get questions afterwards, giving an answer as well. So definitely look online. We will have it posted along with those questions, and we would hope to have everything up and loaded. Additionally, we're hopeful to have these presentations, well, this specific presentation, day 1 and day 2, in multiple languages, so that workers who didn't have an understanding of the presentation can read it in their own language. So we are working actively to have that up and running also as well. And let's see. Thank you for the great. We're getting a lot of compliments. Let's see. So as far as code questions, specific email, the department, if you go online, you can do the general inbox, and I believe there may be a code email specifically for code questions. You will have to check on the website. We've been making a few changes on our website, so I don't want to mislead you. So please go to our website. You can start with the website that we have listed here, and you can go to the DOB website, and you'll have sections where you can find those questions. And you can actually submit questions if you have questions specific to a question that's not being answered. I don't see any other questions right now. So I know there's 2 other questions that are currently being answered at the moment, and they're mimicking another question that has been answered already. So both me and Patricia want to thank you for joining us today. We hope you were able to capture both presentations. If not, again, they were recorded, and this one is being recorded and will be presented online so that you can see it at your convenience. Again, it'll probably take around 2 weeks or so for the posting to be done, if not sooner. So we want to thank you again for joining us tonight. Be safe, be well, and play it safe. Have a good one. Good night, everyone.